Can I start?
Hello, we are from the team ByteMasters, Likit GS, Krishna, Maluk, Kshitij, and myself, Rajesh. So, our topic is crime detection model. We know many crimes happen nowadays, uh, especially these recent days. We are having more and more crimes in the society. So, we have developed a machine learning and deep learning model to prevent and to uh, decrease the number of rates of crime by our models. One of the models is the K-means model, where we find out the number of crimes and the depend on the location. And another one is the image processing model, where we find the crime by the weapon used. So here we use YOLO V5 algorithm, where we developed our model on. So it's a PyTorch, a flexibly wide embrace deep learning platform, which helped us to construct and fine tune the YOLO V5 model and the workflow. We collected the data sets of the images of containing the instances of pistol, and we have trained the model. We have annotated the data using the RoboFlow platforms, and we drew the boundaries for each image of the pistol. Then we processed the data and resized and normalized the images and augmented the data by applying transformation like rotation, flipping, and brightness adjustments. Then we selected, and the model selection went on by using YOLO V5 algorithm, PyTorch as an object detection model architecture. Then we trained the model, which took a lot of time because we had a lot of images. So then we chose the model architecture, batch size, learning rate, and number of epochs as 100. Then initiated the training process. Then we evaluated and post-processed the model, and we got the accuracy rate very high, and the confidence level that it's a pistol was also very high. So the precision was maximum, and it will help for the society in a lot of in a good ways. That is by crime deterrence, rapid response, evidence collection, public safety, crime prevention, and surveillance in sensitive areas. So we are more focused on the CCTV footages, that because using the CCTV footages, we can find out who the person has, how the person has made the crime, and will get an evidence for the for finding the culprit. Now, going on to the code.
Continue, bro.
Uh, First, we have installed the dependencies. That is from we have cloned the repository of YOLO v5, and then we have installed the QR requirement.txt, where it ignores all the errors, and then imported torch. That is a PyTorch. That's very basic for our program. IPython.display, where we imported the image and clear output screens. Then we have installed RoboFlow. This is the main part of our code, because from only by using the RoboFlow platform, we have annotated the images, and after annotation, RoboFlow will give an API key, which we from where we have got the data sets of our images. Then cat is used for loading RoboFlow into our notebook, that is data.yaml file. Now Likit will explain the further.
Yeah, as Rajesh explained how we took the data using API key. Now I want to show you a bit of the RoboFlow where we have uploaded our data, and here we have trained the data also. Here we have used RoboFlow majorly for annotation purposes of our data sets. Now here we will define the model configuration and architecture. In this, we are just uh, importing YAML and just making the file structure proper. The file structure here you can see we have YOLO v5 as our one of that, and then here in YOLO v5 we have created our own folder called ByteMasters. Inside that we have kept test, train, and valid folders. In the test folder we have images, several images which we have taken for training for testing purpose, and in train we have several photos for training purposes. Yeah, so these and all the following codes are doing doing the folder structure, and here we have trained using here while training we have used 100 epochs. Each epoch we have around I will show you around 1.6K training set data, training set images, and 154 validation images, and 77 training set images. So all these images are run over 100 epochs, 100 times. These iterations are done for our efficient model, to make our model efficient, I mean. So these are we have run already, and on running we have got the following graph using TensorFlow. We have run the graphs. Here you can see the F1 curve and all. I want to show you the MAP, the mean average precision graph. Here you can see that on epochs 90 to 100, here our MAP is approximately settling down. So we according to 100 epochs, we have uh, done pretty well in the precision part of our data training. So here we after doing that, the whatever training data will be stored in the following place, that is in the YOLO v5 results in the train batch 0. So the training data we have printed here. You can see the training data. These are the annotated one which we had trained, and yeah, these are the training data. And now after training data, now we will check for the new data, which the data which we had never ran. That is for the test data. So here we have added the test data, that is the sources ByteMaster test images. Here ByteMaster test images. We have taken the all the 77 images. So for those 77 images, we are displaying, we are running our code basically. We have trained our code by doing epochs. Now we are running our code for the new data. So here you can see for the fall, we have got the outputs. And the outputs is for this, we have got 0.66 pistols is the category. Like, what is this? This is pistol, and this square box identifies a dimension of the object, and 0.66 is the accuracy. I mean, yeah. And here you can see the pistol 0.6. 0.54 is the, like, the pistol is the class name, that is what it is identifying, and the number beside it is the uh, confidence of it. Like, if the confidence is more than 40, only we are printing it. So for this 0.5, 0.67, 0.82, 0.48, 0.49, 0.9. So these are the subsequent outputs which we have got uh, for our model. So I want to conclude that by saying that we have done this training the model and for ensuring CCTV. If we put like here the here in these images, you can see that we have trained for pistols. So I want to conclude that we are using this as a safety measure in our society, so that there will be no much crimes by ensuring automatic detection of gun, that is pistols we have done here. So this can be implemented in our society also. Thank you.